So hello everyone, my name is Hazrul Hakimi and today I would like to present about the experiment of principle of moment. Alright, so for the introduction, the principle of moment is frequently used in engineering and building work where forces have to be balanced to prevent any turning movement. It can be applied both to parallel forces and to oblique forces. If a body has several forces applied to it which have turning effects in opposite direction, the body will not the body will not turn if the total turning moment in each direction are equal. This is called principle of moment. For the experiment theory, experimental theory, a concept often used in mechanic is the principle of moments, which is sometimes referred to as a Varignon's theorem since it was originally developed by the French mathematician Varignon. The moment of force indicates the tendency of a body to turn about an axis passing through a specific point which defined as m equal to f times d in nanometer, which f is the action of force, d is the perpendicular distance between f and center of moment. Alright, when forces produce a turning effect, this turning effect can be measured by the product W times A, where W is the force and A is the perpendicular distance between the pivot and the line of the force. The product of W times A is called turning moment of the force. The principle of moment states that the moment of a force about point is equal to the sum of the moment of the forces components about the point. For a body in equilibrium or not rotate, the moment clockwise is equal to the moment anti-clockwise. So F1 over F2 equal to A over D.
Hello, my name is Lim Jie Wei. My metric number is AD 190209. I will present the procedure. First, apparatus setup. Set up the panel board as shown in figure. Ensure pivot bar is in balance and attach pulley using block and nut. For test 1, hand weight hooks from the end holes of the bar entering the hole from the back of the bar. Refer to figure below. The weight of the hooks is weight 0.1 Newton. Then add a 1.90 log to each hook to make the total of 2 Newton. Then record the value of F1 and F2. Then measure and record the distance T1 and A. For test 2, move the weight hook of right hand side to the hole nearer the pivot bar. Refer to the figure below and lock it with just sufficient weight to balance the bar in the level position. Record the weight value F2 and the distance A.
Now I'm going to talk about the procedure for test 3. For test 3, we are going to set up the apparatus as shown in the figure by hanging wet hook from the end holes of the bar entering the hook from the back of the bar at the left hand side. The weight of the hook at left hand side is 2 Newton. Then hang right hand wet hooks without wet through pulley. After set, we are going to lock the wet hook to balance the bar. After balance the bar, we are going to record the wet value F2, which is the wet added on the hook and the right hand side, and also the perpendicular distance A is recorded in the table provided. For test 4, we are going to set up the panel as shown in the figure. the core passing over the left-hand pulley and attached to the lowest hole of the center arm of the bar. After that, we allow the wet hook to balance the bar. After the bar is balanced, we are going to record the weight of F2, which is the weight added on the hook with mark W in the figure below, and measure the distance between the center of the bar down to the string that passing over the left-hand pulley. The result is recorded in the table provided.
My name is Len Chim Quang Hoa. My metric number is 8190215. I will present the result and calculations. For result B, N1 equal to 2.0 times 0.16 equal to 0.32 Newton meter. M2 equal to 2.0 times 0.16 equal to 0.32 Newton meter. For B, N1 equal to 2.0 times 0.16 equal to 0.32 Newton meter. M2 equal to 4.2 times 0.09 equal to 0.378 Newton meter. C, N1 equal to 2.0 times 0.16 equal to 0.32 Newton meter. M2 equal to 2.7 times 0.12 equal to 0.324 Newton meter. D, N1 equal to 2.0 times 0.16 equal to 0.32 Newton meter. M2 equal to 6.1 times 0.065 equal to 0.396 Newton meter. For result C, ratio of forces equal to F1 over of F2. For A, 2.0 divided by 2.0 equal to 1.0. B, 2.0 divided by 0.95 equal to 0.476. For C, 2.0 divided by 2.7 equal to 0.74. For D, 2.0 divided by 6 by 1 equal to 0.328. Ratio of distance equal to area divided by distance. 1. A equal to 0.16 divided by 0.16 equal to 1.0. B, 0.09 divided by 0.16 equal to 0.563. C, 0.12 divided by 0.16 equal to 0.75. D, 0.065 divided by 0.16 equal to 0.41. Thank you.
Hi, I'm Lee Gok Siang from Group 9. So now I'm going to present about the discussion part of our experiment. So now I'm going to talk about part A of our discussion. So part A is about our graph. So the graph of 10 is a straight line graph, as we can see, with a positive gradient. From the graph, we know that f1 over f2 is directly proportional to a over d1. When f1 over f2 increases, a over d1 also increases. The graph and data show that the moment acting on both sides of the bars are the same but in opposite direction when the bar reaches equilibrium. So therefore, the resultant force is 0 and it stays in equilibrium state. So now I'm going to talk about our part B of the discussion. So it is talk about the summation of the moment from our experiment result. So based on the data obtained from our experiment, the differences between the left pivot bar and the right pivot bar are very small, or can say 0, since the system are in equilibrium. So theoretically, the moment of the left pivot bar and the right pivot bar should be equal, and thus we can conclude that the difference in the value of 10 are due to the errors while handling the experiment. So the error can be due to the pivot bar used was old and rusty. This will add additional friction and cause the reading to be inaccurate. Another error are parallax error when reading the value from the ruler. So now I'm going to talk about part C of our discussion, which is if the moment is non-zero. So what are the factors that may influence this experiment? So there will be two factors. The first one is force applied and the distance from the center point. We can obtain this information from the formula of moment, which is moment equal to force times distance. So since moment is non-zero and is the product of force and distance, we know that the factor that influence the experiment are these two. So that's all from our video presentation today. Thank you for your attention.